Hi all, I am K. Surya, working as Assistant Professor in the Department of ECE at SNS College of Technology. So we are going to see a video lecture series on applications of op-amps along with the diodes. So in this video, let us see about peak detector. So peak detector is a circuit which is used to determine the maximum peak or the maximum peak-to-peak signal of a circuit. So this is the basic circuit of a peak detector which consists of diodes, capacitors and resistors. So a typical peak detector circuit consists of the key components like diodes, resistors and capacitors. So the working is divided into four parts. First one is the input signal. So the peak detector starts by receiving an input signal which could be any time varying waveform. Next one is the charging phase where the input signal passes through the diode, so allowing it to charge the capacitor through the resistor. The capacitor gradually charges up to the peak voltage of the input signal. Next one is the holding phase. Once the capacitor reaches the peak voltage, it holds that particular peak voltage effectively until the next peak value is reached. Then output the stage, the voltage across the capacitor is the output of the peak detector, which retains the highest voltage level reached by the input signal during the charging phase. Next, we'll see the types of the peak detector. It is divided into three types based on the polarity of the peak that is detected. The first one is the positive peak detector, in which it captures the positive peak of the input signal. Next one is the negative peak detector, where it captures the negative peak of the input signal. And last one is the peak to peak detector, where it captures both the positive and negative peak of the input signal. We'll see the working of the peak detector in detail. So when you apply an input signal to the circuit, the capacitor starts charging through the diode until it reaches the peak voltage. So this new peak voltage is stored in the capacitor until it is discharged. The diode in the circuit will get forward biased when the applied input voltage exceeds the capacitor voltage, which is present at the output, which is known as Vout, thereby allowing the circuit to behave like a voltage follower. So you know that voltage follower is nothing but which will have the output same as the input. So the output follows the applied input voltage until the input voltage is more than the capacitor voltage at the Vout. When the input voltage reduces below the capacitor voltage, it causes the diode to get reverse biased. So in such case, the capacitor will retain the peak value which it has already detected until a new peak value is got. Whenever the input voltage exceeds the current peak voltage, the diode will again start to conduct because it becomes forward bias and the capacitor will charge to the new peak voltage value. So efficiently setting the output voltage to the current peak value. So this is how the peak detector circuit works. So every time when a new peak value is detected, the output will be set to the new value. If the input voltage is less than the current value in the capacitor at the output, then the capacitor will hold the already chosen value, which is the peak value. So when a new input voltage higher than the stored value is got, that value will be stored in the capacitor every time. So thus the peak value is detected each and every time when a new peak value at the input is given. So this is how the peak detector works. One more modification of this peak detector is resetting the value. So as we know, a peak detector will hold the peak value until it resets or power down. The easiest way to reset a peak detector is to drain the capacitor with some kind of a switch as shown here. The image shows a peak detector circuit with an op-amp featuring a reset mechanism. So we can reset the peak detector by providing a reset signal to the MOSFET which is connected to across the capacitor. It will turn on the MOSFET and discharge the capacitor. If we want to manually reset the detector without a signal, we can simply replace the MOSFET with a switch. So this is the output waveform of the peak detector. So where the input and the output is shown here. The input signal is illustrated in the green color and the output waveform is shown in the red color. As we see, whenever the input signal exceeds the previous peak value, the output waveform increases its amplitude and holds to that value until a new higher peak is identified in the input. An operational amplifier can be incorporated into a peak detector circuit to enhance its performance. The op-amp based peak detector offers high precision and faster response times. So it acts as a buffer and improves the stability of the circuit. So some of the applications are it is used in audio processing, RF communication, radar systems, and medical instruments. In audio applications, peak detectors help measure the peak amplitudes of the audio signals, which is crucial for maintaining the signal quality and preventing distortion. Peak detectors are used in radio frequency communication systems to capture and maintain the peak envelope of amplitude modulated signals, ensuring efficient data transmission. In radar technology, peak detectors assist in processing and extracting critical information from radar return signals, improving the target detection accuracy. Peak detectors play an important role in medical instruments where they help analyze the physiological signals such as ECG and EEG waveforms that are abnormal peaks and patterns. Hope you understood the working of peak detector and its applications. Let us take up some assessment questions. What is the alternate method to measure the peak value of non-sinusoidal waveform other than AC voltmeter? The options are clipper, clamper, peak detector, and comparator. Yes, the answer is peak detector. Next one is the resistor in the peak detector is used to, the options are to maintain proper operation, to protect op-amp from the damage, to get shaped non-sinusoidal waveform, and none of the above. The answer is the resistor is used to protect the op-amp from damage. Thank you for watching this video.